Hello guys, welcome to part 3 dealing with functions, and today we will be learning about the rates of change and slope. What does that represent in a linear function? Alright, our vocabulary for today we have rate of change and slope. Now the rate of change is the ratio of two quantities that change. For example, we can have distance and time. So we have distance changing over time. So to find the rate of change, if we're talking about the distance and time, we need to find the change in the distance and then divide that by the change in time, and that will give us the rate. Okay, so we can use 2 points on a graph. We learned about graphing from last session. So we can use 2 points on a graph to find the rate of change, and let's go ahead into more details with that. Alright, so here we have a graph. So this graph here, it shows the distance monarch butterflies travel over time. So we can see over time is traveling more. So in one hour at zero time, it's, I guess, sleeping, it's not moving. After 1 hour it travels a distance of 20 miles. After 3 hours, it traveled a distance of 60 miles. Now we can see the points in between. So this right here will not be 1 and 2. This is 2. So this right here will be 1.5 hours. So after an hour and a half, it will travel 30 miles, and it keeps increasing. So this right here, so now using this information we can find the rate of change. And so here, since we're talking about distance and time, so we need to divide the distance by the time. Again, we can use any of the points. We can use any of the points because it's a proportional relationship. It's starting at the origin, so then we can use any of the points to find the rate of change. So remember, we're trying to find the rate of change here, which is the distance and then the time. So here we have 21 hour. So the distance here is 20, and the time here was 1 hour. And then here we have the difference is the distance here is 60 miles, and that the time will be 3 hours. Okay, so again here we can go ahead and find the change between those 2 points. Alright, so now once we find the change between we can find the rate of change. So the rate of change here will be going 20 miles for 1 hour. So it's changing by 20 miles every hour. It increase is going to go up by 20. So here we can find, once you find the unit, this one is pretty easy to find because they already give me the distance is 20 miles every hour for 1 hour. So this right here will be my rate. Okay, now let's say we didn't know that the graph did not show us this point. We could use this point here as well to find the rate, which would be 60 mile over 3 hours. And then in this case we will divide them, 60 divided by 3, and that will give us 20 to 1. Again, we divide both of them by 3, so that will give us 20 miles per hour. Okay, so let's go ahead and recap. How do we find the rate of change? So the main thing that we need is to get one point on the graph and then simplify it by simplifying the ratio. Okay, so here we are talking about distance over time. Now I'm going to pretend that I didn't know that the butterfly is traveling 20 miles for every hour. I'm going to use this point to find the rate. So again, it is to find the rate, it's always distance over time. So the distance here is 60 miles over 3 hours. So here we need to find the unit rate. It's almost like the unit rate that you guys learned in sixth grade. But now you guys can really see that's really the slope, like how things are changing. So here again, so we can simplify by dividing both of them by 3. So I could get, and then that will be 20 miles to 1 hour. So every hour is 20 miles. Every 20 miles is taking 21 hour, and you can see the change. At 1 I was at 20, at 2 we are at 40, so it's increasing by 20 each hour for every hour. Okay, let's move on. Alright, so here is another graph. So go ahead and try to find for me the rate of change. So this graph here is showing us the distance a loggerhead turtle travel over time. So please find the rate, like how fast is it moving per hour. Okay, go ahead and try that one and then come back and get the answer. Okay, so now this graph here is a little less confusing. It doesn't give us the one is like somewhere in the middle where we don't really want to be estimating. So let's go ahead and use a, a good point. So one good point that is intersecting 4 squares is 30 miles. So here again, it's always distance over time whenever we are finding the rate, like how fast is it moving, that's what we're trying to find here. So here is 30 miles to 2 hours. So in 2 hours it traveled 30 miles, and then we can go ahead and reduce this by dividing by 2, and we can see it's traveling at a rate of 15 miles for every hour. So we will say 15 miles per hour. We don't have to put the 1 there, but we know it's per hour. That means in 1 hour. Another point that we could also use is this point. That's a very solid point. And if you look at the graph also, 1 is right here. And if you look at 1, it's like halfway between 10 and 20. So we know that's 15. But just to be on the safe side, so we are not estimating what that line is, we use one good point on the graph. Okay, so it will be 15 miles per hour, so that will be the rate of change. So every hour it's increasing by 15. Okay, so now the rate of change is also called the slope. Okay, now the slope of a line is the rate of change between 2 points on the line. For the rate of change, we usually will use 1 point, but for the slope we want to get 2 points because we're trying to see the steepness of the line, how steep the line is. Okay, again, to find slope we need to do the change in y. So it's always that's called the rise. I would always say, I used to get this confused, but what I used to say is that if there's a fire, right, and we have to run out of the classroom, we were all sitting down, so we have to get up and then run. So that's what I remembered. So it's always going to be rise. So first we have to rise and then we run. So that's the slope. So the change in y is the rise and the change of x is the run. So we need to go up and then run. So sometimes we might be going down and then run, from left to right, or up and down, it depends. All right, so here we can find the change here. So how am I getting from this point? Here's one good point. How are we getting from this point to that point? So first we need to rise. We need to rise 1 2 3 and 3 units, and then run 1 2 2 units. So again, it is rise over run. So the slope here will be, again, we have to run 1 2 3. So the slope here will be 3 2 2. Okay, so that means we have to rise up 3 and then run 2. Now sometimes it might be a negative slope, and then we have to do the opposite. So we have to go down 3 and then go to the right 2 times. Okay, so here we need to tell whether this slope here is positive or negative. Okay, so this right here will be a positive slope because we started here and we have to go up. So this right here will be a positive slope if it's going from left to right. All right, and then here we can take a look at the rise. So we need to go 1 2 3 and then 1 2 3. So we are moving into positive direction. So we go up, that's positive, and we go to the right, that's positive. So of course the slope is positive. So the slope here will be 1. Alright, so here we need to see whether this slope is positive or negative. Now because if I put something here, it's going to be going down, so I know this is going to be a negative slope. Now we can also check with the points, so we need to go up 1 2, so that I'm going up 2, and then that will be positive, but this time we are going to the left 1 2 3 to the left. So because we're moving to the left, that's a negative move, so that will make it a negative slope. We know when we divide a positive and a negative, the answer will be negative, so the slope here will stay negative. So again, here we went up 2 times, up 2 units, so that'll be positive, and then we run to the left this time, not to the right, so that right here was a -3. So that was a negative move by moving to the left. So that makes a positive and a negative give us a negative. So the slope here will be negative. Okay, so let's see if this one is positive. Okay, so again here, this one will be negative. Looking at the points, we go up 1 2, positive, we're going up, and then we go to the left 1 2 3, -3. So this will be a negative slope. Okay, so you need to tell if this slope is positive or negative. Now because it's heading down this way, so I know it's going to be a negative slope. Let's go ahead and look at the points. So let's see how do we get from this point, which is a good one, to this point. So we need to rise 1 2 3 4 5 6 7 8. So this was a +8, and then from here we run 1 2 because we're moving to the left again, so it's going to be negative. So the rise here was +8, and then the run on the x-axis is -2 because we moved to the left. So now this could be reduced. So 8 divided by 2, so that will be a -4. So that will be the slope. So the slope will be -4, or we could say -4/1. Whenever it's a whole number slope, the run will be 1. Okay, we just put a 1 under it. Okay, and also we could check it, the slope. There's a point right here. How do we go from here to there? Again, we will go up 1, 2, 3, 4, and then we'll run negative. So that'll be a -4 slope. So whenever you get those slope, please reduce them if they can be reduced. Okay, we can also use the slope to graph if we know a point to graph the line. Alright, so please pay very close attention. So here we have 1 and -1. That's my point, and then we go ahead and plot it right here. +1 on x, -1 on y. And then the slope is -2, 1. So that means I will be going up 2 times, but I will be moving to the left once. Or I go down 2 times, but move to the right once to keep it still positive and negative move. Okay, so here we move down 2, that's negative, and then we move to the right, that's a positive. Positive of a negative is still positive, and a negative is still negative, so that's still a negative slope. Or we can go up 2, that's positive, and move to the left once, that's negative, and that would be a negative slope. And boom, there we go, we have the line. Okay, alright, go ahead and try to graph this one by yourself and then come back and get the answer. Alright, welcome back. So here this time it's a positive slope, so we are going to run once, we're going to go up once and go to the right 2 times, or go down once and go to the left 2 times. A negative and a negative move will still give us positive slope. Okay, so here we go, we rise up 1. My point here, we were starting at -1, 1. We rise up 1, that's positive, and then we go to the right, that's positive, and here is the line. Or if we wanted to see the negative move, we will go down 1, which will be negative, and then we will run 1, 2 to the left to get to this point, which will be negative. So negative and a negative is still positive. Okay, so here goes the line right. That's it for today. Hopefully you guys are not so confused about slope, because we will actually go outside and run so we can find our rate of change, which is the slope of the line. Alright, that was it for today. Have a good one. Bye bye.